Good morning, everyone. Today, myself, Troy, and Faisal will be presenting a project on our car crash and who did it.
So the incident report given was an accident of two vehicles taking place on the corner of Ballarat Road and Hodley Crescent. The Victoria Police have called in a forensic scientist, which is us, to assess the collision and to find out who is at blame. Our first vehicle and our first driver was a Mitsubishi Outlander 2014 Aspire. The vehicle was traveling east towards the city on Ballarat Road. He claims that whilst he was driving, the Audi driver suddenly appeared in front of him and he had to slam on his brakes. Driver 2 was an Audi A3 Sportsback, also 2014, driving on Hodley Crescent, trying to make the red light and turn onto Ballarat Road. He claims that the Mitsubishi driver was traveling at a fast speed, trying to make the red light whilst he was already in the intersection waiting to turn. As a group, we proceeded with the idea that the Mitsubishi was traveling at a constant speed and the Audi suddenly appeared, and we can rely on this theory as it's grounded upon multiple ideas. With regards to the idea of momentum, if the Audi with the initial speed 0 was in the intersection, the Mitsubishi would have collided with the Audi horizontally and they would have traveled in an easterly direction. However, the supplementary evidence provided alongside our calculations, we were able to ascertain and determine that the Audi collided with the Mitsubishi and they traveled in a southeasterly direction. The initial light skid marks of the Mitsubishi, as seen with the thin pink lines in the diagram to the left, unable to stop in time, eventuating in a collision with the Audi driver, as seen with the thick pink lines and the orange arrow. This is indicating the collision path travel. As the Audi driver was turning across the Mitsubishi, the energy in the collision was lost via the debris and tire friction, but the momentum is conserved and carried with the Mitsubishi through the Audi, and both cars, being two separate objects within the system, are now one object traveling together in unison until a halt. This stipulates the idea of the car accident being an inelastic collision, as momentum is conserved but energy is lost. The speed of both cars after the collision is 0 meters per second as they came to a halt. In free body diagram, see the system at stopping. We can ascertain the force acting downwards as the mass times gravity of the system. Slide force is 6.9 meters a second. From future slides, you can see the calculations, and that the frictional force is 0.68 newtons to the left, so acting opposingly of the applied force. This is all based on our calculations.
Our evidence to back up this result mathematically, by using the information provided, we found that the Mitsubishi and we first found the masses of both the Mitsubishi, the drivers, and the Audi driver. We did this through various resources such as car sales, but we found that the mass of the Mitsubishi was 2,260 kilograms and the mass of the Audi was 1930 kilograms, and the information provided said that the driver's mass for the Mitsubishi was 74 kilograms and the Audi's mass is 85 kilograms. We then combined those massages to find the total mass for each object, which being the two different cars. We first found out the determining force, the normal force. We use this by using the formula F equals mg, where mass being the total mass of both the Mitsubishi and the Audi combined times by 9.8, so to gravity, which gave us an answer of 42,620.2 kilograms meters per second. Then we found the velocity of the crash. We will use a D equals V2 over 2UG formula, where when we input all the results given, so D being 3.5 meters equals V2, which we're trying to find the velocity of the crash, 2 times mu, where we found mu was 0.7 times 9.8, which is the force of gravity, which then gave us the formula of V equals 6.9 meters per second. That converted to kilometers an hour, because our original answer was given in kilometers an hour, is 24.95 kilometers an hour or 25 kilometers an hour. We then found the Mitsubishi's initial velocity before ABS kicked in. Well, because we saw tire marks at a sporadic before the incident of the crash, we used the momentum formula, M1 times V1 equals M2 V2, where when inputting all the results given, where the mass was the total mass of the two objects, we found that the velocity was 46.3 kilometers an hour. We then inputted the same formula to find the initial velocity of the Audi driver, where we found the Audi driver was 8 meters per second. We needed to find the results. We needed to find the coefficient of kinetic friction. The coefficient of kinetic friction is found by mu k equals force of friction divided by force of newtons, where 0.7 newtons divided by 42620.2 newtons equals 1.6 times 10 to the negative 5. This can be derived from some of the information given from the dyno test results and also through our own calculations. We then found static friction, which was 0.85 divided by 42620.2, which gave us a mu s of 2.0 times 10 to the power of negative 5. This is also further backed up through our dyno results. To find our frictional force to back up our results, we use mu k times F, where force of friction equals 1.6 times 10 to the negative 5 times 42620.2, which gave us a force of friction of 0.68 newtons rounded to 0.7 newtons. We determined that this is an inelastic collision, so therefore V2 equals m1 plus m2 times the velocity times sine theta over m2. Inputting all those values into the formula give us a V2 of 3.6 kilograms meters per second. Then the velocity after the collision would be always be zero, as we can see that both cars came to a halt, therefore stopped.
The results obtained from our calculation in relation to the accident show that the Audi driver is at fault. Incorporating common knowledge of driving experience, those who are trying to make the light drive faster than those abiding the law. Hence, the Audi speed was greater than the Mitsubishi's at 8 meters per second and 6.9 meters a second, respectively, as the Audi attempted to make the turn and suddenly appeared into the field of view of the Mitsubishi driver. The direction of the accident resulted in a southeasterly direction of 20 degrees below the horizontal on Ballarat Road. If the Audi driver had been stopped in the intersection with an initial velocity of 0 meters per second, the direction of the accident would have been in an easterly direction and for the much less of a distance path. With that being said, the Audi driver's claim is not strong enough with the values calculated or from the general motor rules perspective. The Audi driver claims the Mitsubishi driver jumped the green light, although this is unlikely as the first position portion of the skid marks reveal that the Mitsubishi driver applied their brakes and slowed down to a slower speed from its initial speed before colliding with the Audi driver. It is also unreasonable to believe that the Audi driver was already at the intersection waiting to turn right. If we were to rely upon this, then perhaps the Mitsubishi driver would normally try to maneuver around the Audi driver to get ahead, but also safely without damaging their own vehicle. If it truly jumped the green light, and this can be considered as a police report indicates that there were no signs of alcohol or drug consumption. Another important topic to consider is the Mitsubishi's constant speed before applying the brakes, which is 24.95 kilometers an hour. If this is the case, and the Audi driver was truly waiting at the intersection, would the Mitsubishi driver then not have a chance to brake to a complete stop or to a considerably low speed, since its speed was already low to begin with?